Bryan Reinero is a developer advocate with MongoDB. Bryan, welcome to Software Engineering Daily.
Thank you so much. Pleasure to be here.
The theme of this week is JavaScript, and I want to talk about where Mongo fits into the modern world of JavaScript. But let's start with just some context about Mongo and the general database world. I watched a talk with Buzz Moschetti, who is an employee of MongoDB, in which he talked about the transition from SQL to the unstructured data world, specifically MongoDB. And he said that for the last 40 years, innovation at the business and application layers has outpaced innovation at the database layer. What does he mean by that?
I think Buzz is trying to say that the flexibility and the ability to iterate and program and try new innovative techniques on the application side, the development side, has increased, accelerated in those 4 decades at a rate much faster than the back-end database layer system has. In those intervening 4 decades, we've seen things increase in, we've seen innovation increase on the application side, but then on the database side, things kind of solidified around the relational database management system, this kind of monolithic approach to data stores. Nowadays, that of course is changing with the NoSQL movement and all of the new offerings and new database technologies that are available out there. And that kind of change frees up the way that we handle data in a way that allows us to iterate on par with the rate of innovation that was occurring in the application developer side of application development.
And Buzz referred to the, quote, rectangular or flat file world when talking about SQL. Do you know what he's referring to there? He is referring to the way that we've come to think about data in the last 4 decades is this notion that we need to store it as tabular data, as we need to flatten out that data into row-column structures. That obviously creates some problems because that's not the same way that our application actually thinks about the data. Obviously, there is this notion of object orientation that has really matured in this time and progressed with Eric Evans' book, Domain-Driven Design. That we think in terms in the application layer of domain objects and domain events, and the keyword being objects. Now, the problem is the way that we structure and organize and think about our data on the application side as far as hierarchical structures, polymorphic entities, doesn't map very well or very easily into relational database management systems. So there's a big yearning need for a data store that works well with the way that we've come to deal with our data on the front line in the application layer. And that kind of movement away from flat file thinking, flat data thinking into more rich document-oriented data has actually created an acceleration of development back on the database side in conjunction with document data stores such as MongoDB. So I don't want this episode to be a long comparison of SQL versus NoSQL, but it's worth discussing the trade-offs a little bit more. And a succinct way to have this conversation is in terms of the acronyms ACID and BASE. And I know they're a little bit reductive, but they are a nice shortcut for having somewhat of a conversation of the trade-offs. What do each of these acronyms mean, and how do they represent their respective database type?
ACID transactions refer to, these are the terms coined by Eric Brewer, I believe was the BASE, coined the term BASE. ACID, of course, is what we've come to know as atomic, consistent, isolated, and durable transactions. Now, in the world of relational databases, the scope of those ACID transactions apply to, depending on, of course, the storage engines that you're using in different relational database systems, they've been come to be known as and associated as consistent and isolated transactions on multiple rows. Okay, meaning that if I'm going to
perform a mutation or a modification of a piece of data on one row, and it affects multiple rows. That operation, that write operation, affects multiple rows. All rows are consistently and atomically updated or not. In the NoSQL world, in MongoDB, the scope of the ACID transaction is going to be within an individual document or an individual record, if you're thinking in terms of trying to translate between SQL relational world and MongoDB. So there are atomic operations, there are consistent operations, there are isolated operations and durable operations in MongoDB, but the scope of those are going to be the individual document. You won't have an atomic operation across multiple documents. Now, that may seem like a limiting kind of operation, but it depends on the scope and scale of the database system that you are that you're operating in. The realm that MongoDB is designed to tackle, in addition to being, let's say, an individual standalone database process, is the capability to scale up to a distributed massive system that could be some terabytes, many terabytes in size. And because it has this need, or it's designed to be able to scale up to those sizes, we're going to be dealing with a distributed data set, and we're operating as a distributed database. And in those conditions, enforcing atomic transactions across multiple documents, which may not reside on the same node or same server, is prohibitively time expensive and not practical in the real world in systems of scale. So the way that MongoDB operates is that the operations will be atomic and consistent in the scope of the ACID transaction is, of course, again, to the individual document, but we don't want to sacrifice that speed and that ability to scale up by having enforcing those atomic transactions across documents. This isn't so much a limiting factor because the data model itself is written in JSON, or the basic underlying data model of MongoDB is this rich, nested, self-descriptive data object, a JSON document. And you can have a much more expressive kind of data individual record that doesn't really need the idea of joining or enforcing atomic transactions. The data entity that you're working with doesn't necessarily have to be accrued or aggregated across multiple rows. And so I think some of the critics of NoSQL, people who say people are adopting NoSQL too aggressively and thinking about how they're going to need to scale. There's this great talk by Martin Fowler where he talks about how when he hears people saying, the only people that are going to need these scalable large data stores are Google and Amazon because we don't have a need for that data right now. He draws an analogy between that and people who say, oh, I only need a 56K modem right now. Why would people back in 1995 or whenever everybody was on dial-up. So it seems like there is this transition where that is occurring, or it's going to occur, between people who are just using NoSQL databases because they're convenient and they're agile, to a situation where people actually need the scalability that also comes with a NoSQL database. So maybe you could delve into that transition a little more and the factors that are driving it, and how soon you think people are really going to. Well, I mean, obviously, companies like Google and Facebook, they are logging that scale of data, they're operating on that scale of data, but when is it going to happen where, like, Joe Schmo in year one of his company needs that scalability? There's lots of examples about it. Google is, of course, and Amazon are systems of massive data. But the infrastructure world that we deal with is changing, such that I could have a startup that I want to start building and coding for that's a social app. And that could, even though I'm in my first year, if I'm successful as a social app, it's easy for me to expect that I'll get mass adoption. I go viral in my popularity, and the amount of data that I'm going to be dealing with and storing, the hot data set that I'm going to be working with is quite large, especially with user data, interactions, notifications between users. That's very easy to imagine that scale of data is going to grow very, very fast. I think the fun part of where we are right now in the industry is that there's so much ability to do new and imaginative things. The prior restrictions, both in cost and maintenance, are going down in terms of what's available from Amazon Web Services, Google Compute, Cloud Compute, Rackspace, what have you. Infrastructure as a service is providing a lot of opportunity for people to put applications together that accrue a lot of information, and the infrastructure is dynamic and elastic and scalable for them. So they have this opportunity to accrue all of this data, and they're going to need a system that manages it very well. The expectations about the size of data is growing along with it. The user experiences that we have about high availability and low latency when we as users interact with these new systems as well. People expect high uptime. And so the databases that we use now have to face this kind of changing expectation, user expectation, environment, and the way that these new systems are opening doors on a bigger scale than we've ever done before for more people, more high-tech businesses to use than have been available before. And so the key here is that the people who are going to take advantage of the new database technologies such as MongoDB that allow you to scale out and have high performance and high availability, as well as agile development, are going to be the real winners in the next 5 to 10 years.
And so we didn't go into base too much, and I just want to touch on that to discuss some of the frictions that you can encounter with a NoSQL data store. So base was, like you said, it was coined by Eric Brewer, who also described the CAP theorem. And base is relevant to the CAP theorem because it has a tangential relation to like when is your data store consistent, when is it available, when is it partition tolerant, and so on. So base stands for basically available, soft state, eventual consistency. What do those things mean, and how do they apply to Mongo and just NoSQL, and, well, I guess specifically Mongo?
Yeah, so base is an interesting term. It really starts to come to the relevancy.
And by the way, I should stress that Eric Brewer does say that base is a sort of contrived thing, and it's not this like rigid idea, just like CAP.
Yeah, I caught the Eric Brewer interview. By the way, I have to say, not to sound like a sycophant, I'm a big fan of SE Radio, and I listened to all the new episodes, and I thought the Eric Brewer one was particularly great. He's a very interesting guy. There's one thing to note about all these terms: acid, base, cap. And we can go in more detail about the nuances of each of those things, is they're fluid definitions. Base is the understanding of base and what it means in terms of MongoDB. It comes more relevant in the realm of a distributed database. So the idea here is that if we let's say we're talk about a development cycle. I'm starting out, I'm building up my application, and I'm going to be doing my basic development with a single instance of MongoDB, a single process that I'm doing iterative development and testing, that agile development. As my development cycle gets closer towards production launch, I start thinking about how I need to deploy both my application layer for high availability and also my data store for high availability. The notion is, of course, if the data store is down, it is a dependent point for my application. So my business availability is dependent upon the database being up as well. So I don't want to deploy with a single point of failure, a single process, or a single node. I want to use some kind of mechanism for high availability, and in MongoDB, that's the replica set. So in this case, what a replica set is, it's a cluster of redundant nodes associated together, such that when I use the database, if one of the nodes should fail, let's say I have a primary and secondary replication, that is that when the replica set is initialized, the nodes identify themselves to one another, check on the health of one another, and determine if a primary needs to be elected. When the replica set elects a primary, that primary node is now responsible for writes that come into the database. The secondaries will replicate from that primary. All the writes that occur on the primary will be replicated to the secondary, such that if the primary should fail, the remaining secondaries in the replica set will detect that failure and elect a new primary and continue on automatically and maintain high availability. So in these systems, we have a cluster of nodes brought together in a replica set that provides us our availability for automatic failover in these conditions. Now, we can get into these ideas of the other part of eventually consistent as part of the base idea. There's a number of different ways that I can configure the way my client is going to interact with a replica set. By default, MongoDB interacts with the replica set in a strongly consistent fashion, meaning that the clients will always read and write from the primary node. So they get the last write that went into the primary. If I'm reading from that primary as well, I see the consistent changes that occurred on the data that I've written to most recently. Now, I can configure my system to be an eventually consistent system by sending read operations to secondaries if I choose. But of course, the trade-off that I do with that by running in that kind of configuration is that I may not see the most up-to-date operations that have occurred on the primary node, because there is necessarily always a replication lag from the primary to the secondary.
So essentially what you're describing is that there is a gradient of speeds with which you can propagate updates to the different clients. So,
exactly.
So just so we can give an example, let's say we're building the next Facebook, and it's just a complete clone of Facebook. What are some different types of speeds of propagation that we would have for different purposes? So, like, we've got commenting, we've got photos, we've got all the features that Facebook has. How would we configure these different things in different ways so that they would have a level of consistency that is appropriate with how quickly we need the entire system to feel consistent?
Yeah, so most often with users who of Facebook, like a Facebook-like application, I want to post something. I want to update my status, and as a user, I want to be assured that my most recent posts, I want to see them. I want to refresh my page and see that my post has just been accepted by the system. On the back end, that means that I when I make a post or I change my status or something about myself that I'm putting onto my user page, that write, of course, will go into the primary. And if I want to immediately confirm that went in and has been accepted by the database, I refresh my user page and I see that my changes have been accepted by reading from the primary as well. So I read my own writes. Now, some other kinds of, if I'm updating a photo or something like that, or metadata about photos, things that I don't necessarily need high consistency on, I can choose to read from the secondaries and get some degree of scale out by reading from secondary servers rather than the primary. The issue becomes that there will be this replication lag. Now, if I've configured my system correctly, As I said, the nodes in a replica set are redundant nodes. They're there to pick up the primary status if the primary node should fail. And for that reason, they should be allocated with the same hardware specification, because they have to, any one of those nodes could become the primary. So they need to be able to handle the same load that the primary would use. So for that reason, if the primary and secondary nodes are the same hardware specification, they have the same disk capacity, disk I/O, throughput, bandwidth availability, memory, CPU, every write that occurs on the primary can be consumed by the secondary, or applied or replicated to the secondary just as fast as it occurs on the primary. The only difference is the lag that it takes between the write occurring on the primary and then being propagated out to the secondary. This is going to be a function of network latency. Okay, so at least theoretically, the fastest that propagation can occur is the speed of light. But then network latency can get involved in changes. Sometimes there's partitions where replication can take longer or shorter periods of time. That generally is the secondary should be able to keep up with the primary just as quickly as the primary is handling those writes. So the real factor in replication propagation is going to be based on network latency. The kinds of operations that need to happen, like if I'm updating a set of data that has lots of index operations, it might induce more load if there's a lot of I/O that I need to do. I'm a heavily indexed collection, or there's a lot of changes to larger documents. Of course, that's going to induce a greater amount of work on not just the primary, but the secondaries as well.
What might be a user level operation that would be an example of that?
A user level well, let's say that I'm going to do an import of bulk import of data. I'm seeding a new data. Or initializing a new system, or ingesting data from onboarding a client, or I'm servicing data from onboarding, as I would say, onboarding a client that has a number of users that I want to pull into my system so that I can do things like maybe serve ads to them, or I'm pulling lots of data into the database.
Oh, okay, so in the Facebook example, maybe this would be more of like a back-end, like data warehousing process.
Yeah, that kind of thing can be a heavy load that might take. You're importing a bunch of records over a period of time, and that's going to induce a lot of I/O because there's lots of data that's coming into the system. Generally, in the Facebook kind of model of way, is you're seeing lots of random load being generated by users that come into the system and update their statuses. So there's lots of individual operations on an individual user basis. But in aggregate, we're talking about many millions, if not billions, of people updating and changing their status and getting notifications of status changes of their friends. So in those cases where you start to get into these massive scales of high operations, the way that MongoDB handles that need to be able to handle higher and higher loads of data is to use sharding, which is an idea that is based on horizontal scaling. If my current deployment of MongoDB, I'm saturating my I/O channel, I'm exhausting how much RAM I have available on the system, I can always scale up by adding what we call shards into the cluster. I scale out horizontally by adding more servers and dividing up the load and the data across those servers, distributing the data across those servers, such that I can always continue to service many inbound requests and higher loads. There's not really I'm not tied to the biggest box or the most expensive hardware available in the system. I could scale out also by increasing the number of commodity servers that I use as well.
So another term I think is worth discussing is polyglot persistence, which is the idea that as time goes on, we're going to use multiple types of data stores while we're building a single application. So what are your thoughts on this? I mean, do you think that are we frequently going to see applications that, even in the future? I mean, right now it seems like we definitely end up with some polyglot persistence just because people have MySQL just like left over from kind of before Mongo was a widely accepted technology, and then their newer stuff is maybe built using Mongo. But you also there are also plenty of new applications that are written purely in MySQL or part MySQL and part Mongo. So what is your perspective on polyglot persistence?
Yeah, it's an interesting space. The first ways that I see polyglot persistence being that your application uses multiple database technologies. And in the early days of adoption of MongoDB, one of the patterns that we saw is that MongoDB would be servicing the front-end application servers, essentially acting as a caching layer for a legacy SQL relational database in the back end. Companies had this existing application and a need to scale out, so they would put MongoDB ahead of it to service the applications, the blades that were talking to it, the client side. But as they matured and as they got a better understanding of how to use MongoDB and familiarity with it, those back-end relational systems start to become retired and eliminated, and then MongoDB becomes the system of authority for the primary database. But there's room for different types of database technologies with the notion that you're going to be using the right tool for the right job. Polyglot persistence can also apply to, let's say now I've been using MongoDB in service to my client side, my client application. I've got lots of great performance. It's a great application database. I've accrued all of this information about users. I've been logging events. I need to perform some kind of analytics to do maybe audience discovery, market segmentation, whatever it is that I need to know about this operational data that's in MongoDB. I can perform analytics and reporting to a degree in MongoDB using things like the aggregation framework, but I might want to use more sophisticated analytics libraries like Apache Mahout. So I would hook up a Hadoop HDFS cluster up to MongoDB and start pulling data out of MongoDB into the HDFS system to process with Hadoop or Spark through what we call the Hadoop connector. It's a piece of code that we provide in MongoDB that allows you to connect up to HDFS systems or even execute Hadoop jobs against MongoDB, the cluster itself. So now we're getting into a different way about how we're managing our data in different systems for different purposes. MongoDB acts as an application database, being able to service my online transactions, and then my analytics is handled with a Hadoop Spark cluster. Now, in addition to that, I can also use other databases. Maybe at this time I want to take a subset of the data that's in MongoDB and perform some kind of additional analytics in a relational database that sits alongside of it. A smaller subset of the data, but the main benefit there is that I can use other existing BI tools that are geared, that are very useful, but they're geared from the SQL world. So I can export some of my data, ETL it into a relational database, and then you leverage existing BI tools for that purpose.
So up till now, we've talked about a lot of aspects of MongoDB that are true across the board, however you're using MongoDB, whether you're using it with Java and Spring, or you're using it with Ruby on Rails, or you're using it with these newer pure JavaScript frameworks. And I think that there's been a drive movement towards these JavaScript frameworks, and I think they're becoming increasingly popular. And that's why the theme of this week is JavaScript. So let me ask you: is there any is there anything in particular about the way that these new JavaScript frameworks work with Node and modern development converging towards single-page web applications? Facebook is a good example of a single-page web application. Is there anything that is unique to these things that makes them synergistic with Mongo, other than the fact that Mongo has JSON as a first-class citizen?
I would say in addition, just the trivially, people come to think that MongoDB is going to be a great fit for their Node applications by virtue of the common JSON document format that it uses.
Which I shouldn't discount as a small piece, because it's obviously having JSON as a first-class citizen is super important, and it really speeds up development. And I would say it's a large performance improvement just in the sense that it speeds up developer time.
Yeah, absolutely. But beyond that, the reason that MongoDB is actually a very, very popular database for people who use all major languages like Java, Ruby, Python, not just JavaScript or Node-based applications, is the idea that the document itself, though it is JSON, can represent domain objects in a much easier fashion than traditional relational database formats. The idea with a document store is, of course, that we can have nested objects, which can be thought of as members of an object in our application layer. The idea that we can represent fields as arrays of sub-objects themselves. So we can do an idea of a multi-element array has meaning in MongoDB. The upshot of all of this is that the way that I interact with the data in the application layer doesn't require a difficult to implement, difficult to maintain, difficult to reason about data model that must be persisted through an ORM layer. That translation from the object that I'm using in my application layer to what's actually stored in MongoDB is very, very simplified and thinner, diminished. So that gives me a lot of great advantages in addition to just having, let's say, key value pairs or a flat JSON document. I can have now polymorphic entities and with hierarchical structures.
How would you describe, what is your definition of an ORM?
An ORM is an object relational mapper. So it takes what we understand to be something like Hibernate, is one of the original classics.
Or Active Record, right, for Ruby on Rails application developers?
Yeah, exactly. And the idea is that we represent these objects, these domain objects in the application layer, and we then need to translate them into columns and rows. Doing so, it can be quite difficult. We have to have this translation into insert statements through SQL, and ORMs are this idea that we're going to handle these object translations in a little bit more easy to manage way, so that we're not reinventing the wheel. That every time that we change our object model, we don't have to rewrite all of our. We're decoupling the database from the object model in the application layer, but there's some penalty to pay for that. There's additional complexity of the ORM layer. Are we confining ourselves? Are we restricting the way that we can store and mutate and change objects in the application layer from how they can be represented in a relational database? Traditionally, polymorphic associations have been very difficult to map into a relational database. In MongoDB, there are a set of ODMs, which are object data mappers, or object document mappers, if you like, since we're not a relational database, so the naming convention is more accurate that way. And you can use those. They are much simpler
because that translation is much easier to accomplish from object into the data model of MongoDB or the document data model. And they're of value for enforcing a schema, enforcing a data model from the application layer that will be persisted in MongoDB. And ODMs enforce that kind of standard. A lot of people use it that way.
Right. So there's a YouTube video that you've probably seen. It's like coined the joke, the MongoDB is webscale. Have you seen that video?
Yeah.
Okay. So in the video, there's like these two developers, and they're talking about what database they should use for an application. And one of the developers is suggesting SQL, and the other one is suggesting MongoDB, because MongoDB is, quote, webscale. And it's clear from the conversation that the engineer that is suggesting MongoDB doesn't really understand the set of trade-offs that he's getting with Mongo. So as a developer advocate who spends a lot of time in the wild talking to developers working on different applications, you have probably seen conversations like this. So how do you clarify things to the MongoDB advocate? And on the other hand, how do you defend MongoDB to the SQL advocate?
I'm very aware of the video. It's pretty funny. It's interesting.
And I'll put it in the show notes because it is it's hilarious.
In fact, as we during our convention, MongoDB World last early June, we actually had some shirts that we got in contact with Extra Normal, the publisher of the video, and we made some shirts that showed the bear, and MongoDB is webscale. So we have a soft spot in our hearts. You owned it. Yeah, we have a soft spot in our hearts for those videos. The interesting thing about the MongoDB is webscale video is it's the problem the kind of joke with that is that people adopt technologies without understanding how it's going to work for them properly. So the way that I approach this with customers who are comfortable with an existing relational database, or they have a degree of knowledge in SQL, that's what they're comfortable with. The idea is just to say, well, let's talk about what your business logic actually is. What are you trying to do? I can give you a litany of all the advantages about what MongoDB is about and what it's designed to do, but let's put it in brass tacks about what you're trying to accomplish. And so that idea of demonstrating that it's not this crazy thing, that there's a reason that MongoDB has a document model, and there's a reason that it does not enforce joins on the server. These reasons are for performance and scale. So it's helping people lead through what their particular problem is, how they want to use their database, and illustrating how the laws of physics don't change with databases. There's still common issues that any data store has to deal with, but the approach that MongoDB is using, the architecture, allows you to solve a lot of these problems with scale, with representing objects in the data store, with high availability that were previously very difficult to tackle with relational databases. Part of the thing that I also feel with experts in the relational world is, everything that you've learned is of value, and it's going to help you understand how to use MongoDB. It's just the approach is a little bit different. One of the ways of thinking about relational models and the normal forms, one of the things that we talk about is, when was the COD paper published? 1970. And what in the world?
What paper?
The COD paper, where he's talking about, he defines the three normal forms are defined.
Okay, yes.
Yeah, the COD white paper. And that was published back in 1970 because the problem that they were trying to solve is this idea that disk was expensive, it didn't have a whole lot of capacity, and it was not very well performant. And so you're designing a database management system to solve a problem
about storage efficiency some decades past. It turns out that relational worked very well for many, many decades. There's nothing wrong with the normal forms. They're there for a reason. But the reason that you normalize may be different and than the reasons that you're going to use denormalization as far as getting advantages of scale and high performance. In both cases, the schema design and the indexing strategies that you use in the database are very, very important. But the approaches that you take need to reflect what you're actually trying to do in your particular business logic, your use case. How frequently are you going to be sending operations to the database? What is and what is the weight? What is the load of those operations? What are your availability concerns? What is the latency that you need? What is the size, the scope of the data that you're using, that you're going to be operating on? And so that's basically the notion. We walk through the design and take an idea of, let's speak specifically to your problem space and solve that problem with MongoDB. Oh, please go ahead.
So you would never say to the. I mean, would you ever end up saying to the MongoDB as well, like the guy that's advocating MongoDB? Would you ever end up saying to him, you might be better off using MySQL for this situation?
Certainly, if there is a case, if there's a specific task that he needs to perform that requires the relational model, that requires cross-record atomic operations. But
if he just comes to you and says, "I've got a rigid schema. I'm pretty sure this schema is never going to change," would you still suggest Mongo?
Certainly, because this is actually something. This is a good question, a good point. People talk about schemaless or that this is somehow MongoDB is only for unstructured data. I think in terms of unstructured data as being free text. People have kind of associated, I think there's a bit of a confusion about this idea of unstructured data and schema-free or schemaless data. In MongoDB, document structure is very important. Indexing is very important, what we would call your schema design. In fact, it is the biggest factor in performance that you'll have in MongoDB. So those things are very, very important. The thing to remember with MongoDB is that we use the term flexible schema because you have the ability to have different types of objects accepted into MongoDB as long as it's well-formed JSON. There's no violations there. There's no corruptions, and the data types are accepted. The idea here is that because the shape of my objects, the shape of my entities that I'm taking into MongoDB are different. They may be related, but they are polymorphic in their nature. Doesn't mean that they don't have, that the structure that they have is unimportant. The structure can be flexible, but it's still there. It's still important that I have these fields. It's important that these fields are of this data type. And that my document is ordered and built in a certain way that my application can understand. It's very important. So the benefit, though, of MongoDB with the idea of the flexible schema is that as my data model changes over time, not just in development, but as my application and my business matures, the data model that I use is likely to change as well. And that's MongoDB will accept those changes, will accept that evolving data model without having to do things like migrations or alter table statements that you're going to have to perform in a data migration involving downtime and a lot of stressful maintenance routines. So
go ahead.
No, please.
I was going to say, let me ask an orthogonal question. So let's say I'm developing an application, and I've got the business requirements, and I've got all the architecture written out, and I've decided I want to use a NoSQL database. And I know that there are trade-offs between different offerings. There's MongoDB, there's CouchDB, there's RethinkDB. What are the requirements of my application that I need to write down in order to make the best decision, and how would I contrast those different databases along the axes of those different requirements?
It's an excellent question. First of all, you think in terms of what it is your application is going to be requesting from the database, what it needs to get, what it needs to store in the database, and what it needs to get back from the database, and how it's going to locate the data it's requesting. So the major features of MongoDB, in addition to being a document store, is the fact that we have secondary indexes, for one. Secondary indexes meaning that I can locate documents not just by a primary key, as a key value store is restricted to doing. I can declare multiple additional secondary indexes on fields within the document and use those to facilitate a broader set of access patterns or query patterns. So that's a huge advantage. The other idea, and the reason MongoDB can do that, is it's truly a JSON document store. In that idea that you said that JSON is a first-class citizen in MongoDB. Although I could store JSON as a string in a key value store, the interpretation of that JSON document then has to be made on the application side. I can't query for sub-documents. I can't query for subfields. I can't make projections on a JSON string the way that I can in MongoDB. If it's an individual field that I want to project back as the result of my query, I can do that, or a sub-document. I don't necessarily have to always be dealing with the entire document as a result. The other advantages that MongoDB has is the out-of-box strong consistency. Because we write to the primary node, and all reads by default go to the primary node, you have a data model that is strongly consistent. I will see changes, the most recent changes to the document that I've persisted back to MongoDB. That's really great. Some other NoSQL databases, they can't enforce that because their contract with the application, the contract with the user, the thing that they're designed to do is always be write available. But as you know from the CAP theorem, is if I'm available and partition tolerant, I'm going to have to sacrifice consistency. MongoDB is its contract that says, well, we'll be partition tolerant and provide you with high consistency. Should the primary fail, there will be moments during those failures that the database can't accept writes because there isn't a primary available. We're electing one and recovering from the loss of this node. But when it's back, you will have consistency on your data when the new primary is elected. And that's a very strong and compelling feature. A number of our clients may need to have high availability over writes, but in general, what I find is the lion's share of database use cases require higher consistency, because the primary failing is an event that is in the 5 nines. You know, if I've properly provisioned my system, it's not often the primary will fail. There is, of course, a probability associated to it with hardware failures and network partitions and whatnot. But most of the time, I need consistency on my data. That's a big one. And this idea that there's a scalability, that I can continue to add shards without downtime. I can scale up or scale down my cluster. I can add more secondary nodes if I want to increase the level of availability that I have by increasing the redundancy of an individual replica set. Okay. So those are the major things. Asking users what their requirements with regard to downtime, SLAs, how much time do they need to recover. There's that notion that it's not just how much, what's my SLA as how much uptime do I need to be on a month basis. It's how fast do I need to recover from an outage. That factors in. So for users that need high consistency, strong consistency, scalability, low latency, and facilitate a broad set of query patterns and therefore secondary indexes, MongoDB is that great choice.
As a developer advocate, you're in a unique position to communicate with engineers. What are the conversations that you have with developers most often? And this is not just a question specifically about Mongo, just a question about because this is a show about engineering in a broad context. Not in there. While there are themes, I am interested in getting the broader picture of the engineering world and painting a description of what it looks like. So what are the conversations that you have with developers most often?
The conversation that I have most often is I find I want to understand what their business logic is so that we can start thinking about how to configure a system for them. What's interesting about the changes, the availability of new technologies and infrastructure as a service is that I find that the field of engineers who had worked in distributed systems had been previously very small. Very smart engineers just didn't have an opportunity in their careers to work on distributed systems. But that's changing, and a lot of people are starting to work in more and more distributed systems. So a lot of the conversation is, okay, we want to, we can model your data, we can get you running and have a good schema designed for you. Let's talk about...
It's like that quote recently, or I don't know how recent it was, but there was some guy, he said, you're building a distributed system. Like regardless of what you're doing, you are building a distributed system.
Yeah. It's anytime, and a distributed system could be as simple as two separate processes talking to one another on the same machine, but they are separate processes. Michael Nygaard's great book, Release It, talks about all the things in a distributed system that go wrong. Anytime that you have two processes talking to one another, that's a point of integration. And those points of integration are where things typically will fail or cause problems. So a lot of the things I talk about with engineers is understanding the nature of distributed systems, thinking about all the edge cases, corner cases, and failure modes that can occur, and making sure that they understand how they need to set up their system for high availability and be prepared for those kind of weird things that can happen in a distributed system. Part of that conversation, too, is I'm a big proponent of the DevOps movement. Previously, a lot of these engineering teams, you had your developers, and they hand off the application over to the operations team, and the operation team may not have been time for good documentation. They don't know what it is that they're trying to support here. I'd really like to encourage dev and ops teams to work in conjunction with one another and open up those channels of communications so everybody understands that they're working and supporting the application in production. They're familiar with it. You show respect for your colleagues in your engineering departments. And so educating developers about the issues that are likely to occur in operations in supporting an application in production so that they can design their application in a way that makes it easy to maintain, easy to detect strange conditions, easy to detect error modes. And then in the operations team, facilitating that notion of this is what the application is, how it should behave. Here's the load that's expected to come into the system. This is how you recognize if there's some change in the way that the application is using the database. You can identify when there's a problem, there's a change in this pattern because you're familiar with the normal operating mode. Now, the DevOps movement is a lot about the engineer who develops the application then must support it. I think that's a great idea. But what I see out there in the engineering community, the engineering culture, is there's still developers and operations teams that are somewhat separated. If the same developer can't be the person who supports the application in production, fostering that communication is going to be very, very valuable. It's going to make everybody sane. It's going to improve the quality of the product and also the quality of the engineering skills on either side. And so that's a lot of those conversations. think clearly about what it is that you want your application to do and what it needs from the database. And then from there, think about all the things that you need to make sure when these distributed systems may fail in ways that you couldn't have predicted, or ways that are hard to detect. Maybe not a hard node failure, but one that is flapping for some reason, and what kind of ripple effects that's going to have around your application stack.
So that's great. So I know we're up against time, but is it cool if I ask a couple more questions? Are you?
Oh yeah, absolutely. I'm really enjoying this, so I can take
fantastic.
it if you can take it.
Definitely, yeah. So is the goal of companies, most companies these days have developer advocates or evangelists or something in that role. But does the term developer advocate, does that mean your goal is to advocate the wishes of the developers that you encounter back to the company, or is your goal to advocate a certain technology to developers?
I think it's funny because the title, I've gone around with it myself. In fact, we've tried to think of something that was more descriptive. Yes, to both counts. Because, well, number one, another term for developer advocate is technical evangelist, but
right.
That has weird connotations and it doesn't sound very rational. And I'm more about like, well, let's take I'm very passionate, but let's take irrationality out of this and let's conquer the problem. Let's think about it, and there's always a solution. So I don't like evangelist. Nothing wrong with anybody who has that title. It just has a wrong connotation. So prior to this, I was a consulting engineer in MongoDB. And I've been an employee of MongoDB for over 3 years, and my role was a consultant. So the fun part about that is that you go out and you just make people successful. That's the only thing I needed to do, which was very satisfying. I would tell the people that I was working with, look, I'm just here to make you successful with MongoDB. If you're not successful, I'm not successful. Now, when I transitioned to this role as a developer advocate, I still feel that that's my job. My job is to help people understand the technology and use it successfully. But that advocacy, I think it does work both ways. I'm there to say that you can get the job accomplished with this technology, but I understand things from your perspective, and I'm an advocate for your success. And if there are problems or wants or wishes or nice-to-haves that you would like to see MongoDB, new features that you'd like to have MongoDB have, or directions in our development, yeah, my ears are open. All of our ears are open here at the company. We want to know how MongoDB is being used, how people would like to be using it, because even though we've been around, the database has been around coming up on 6 years. That is a high level of maturity for the non-relational MySQL arena. But it's still a new technology, and there's a lot of excitement about what a JSON-based document store can be in the future. So there's a lot of tell me what your pain points are, tell me what your successes are, tell me the ways that you're using this in new ways that are innovative. So that's a extremely satisfying part of the job, is that back and forth communication, and the advocacy always works the same way.
And MongoDB is open source technology, but is mostly developed by MongoDB Incorporated, which is where you work. The open source company model, it's come a long way since the days of Red Hat. Like, now there's a lot of companies that have a combination of open sourced, it's almost like open source technology, closed source business strategy. So what are some interesting aspects of working within this open source company model?
The accountability. So I came to MongoDB originally as a developer for the Java driver, and that was a lot of fun. And that was my first kind of experience as being an open source developer. And the appeal to me is that.
And by the way, side question is would you just define a Java driver? Is that like how does that compare to a to like JDBC or like the Java equivalent of an ORM?
Excellent question. So the Java driver is all of our drivers, and we support 12 of them. There's for all the major popular languages out there, and there's also community drivers that we kind of help with. Community drivers being those that we don't officially support, we don't have engineering resources on, but there are other engineers in the community that. Like for instance, there's an R driver that is supported by the community, and we exchange information with the community developers and help them with the standards and things like that. But we do support 12 official drivers, Java being one of them, Node being one of them. The drivers in MongoDB perform a couple of basic functions. One, most obviously, is they have to maintain a connection pool, in some cases for multi-threaded drivers, a connection pool, a thread pool to the database. They maintain and manage that connection to the database, whether it's to a single standalone instance or to a replica set or a sharded cluster of many hundreds of nodes for very, very large-scale deployments. Once they have that connection to the database, they need to do things like authenticate themselves. They need to talk through the wire protocol that we use between the driver and the database. And then, of course, handle changes in database states such that if there's an election of a new primary, the driver understands what that change in the replica set composition is and can respond accordingly. So, for
this
instance,
sounds like it's one layer below the ORM.
Yes, that's correct. You don't need to use, and just to be a stickler for detail, for the ODM.
Okay.
Yeah, ODMs can be used. A lot of the drivers, for instance, we have a supported ODM called Morphia, which is built on top of the Java driver, and then your client application interacts through MongoDB through the Morphia ODM. So yeah, that's an underlying connection manager to the database and wire protocol manager to the database. And that's where I originally came aboard, and that's the basic functions of the drivers.
So to get back to the open source question.
Yeah, so the appealing thing about it was I was coming from a very large online advertising company where I managed many hundreds of application servers that was dealing with tons of hits per second, tons of flow of data, and I really liked the challenge of handling that scale of deployment of a system. When it came time for me to think about something I might want to do in the future of my career, I had been using MongoDB a little bit, and I was very interested in it. And I came aboard as a Java driver. The new challenge was code quality, making sure that what I was contributing was good code. And that's the interesting aspect of the open source model, is that it improves your code. It improves any engineer's code quality because it's out there. Anybody can see it. And add constructive criticism as well. You're putting code out there, people review it, they want to make sure that they like it, they want to make sure that they understand it, and they'll say like, hey, what if we tried it this way? And can introduce you into new ideas that is really beneficial. I feel that being involved with those open source projects, of course, increases your skill set, accelerates the skill accruals that you have in just an amazing way. And also that there's a lot of, with the open source model, there's this notion that an interesting aspect of it is that there is confidence in the product. If the code were proprietary, there's a feeling that, well, what if this company goes out of business? If the code is proprietary, I don't have access to it. I'm kind of at the whim of whatever the maintaining entity, the owner of the code base goes or does. Open source allows you to inspect the code, reason about it, investigate it, make your contributions. We take pull requests from the community, not just in the drivers, but from the servers as well. So it's a really great strategy for building confidence in adoption, not just in grassroots community areas, but in businesses as well. Enterprise businesses have higher confidence in open source. So that's been very gratifying. The community of developers out there that get involved is very high as well. And those interactions are extremely satisfying. What you can learn from your users, what you can learn from the people who also contribute. Knowledge sharing. That's a lot of fun.
Cool. Well, that sounds like a good place to close off. Bryan Reinero is a developer advocate with MongoDB. Bryan, thank you so much for coming on to Software Engineering Daily.
Thank you so much. It's been an absolute pleasure, Jeff.